Hey guys, this is a recording for continuation of 3.5. On the last video, I asked you to do example 1C on your own. So these are the two acceptable answers. Hopefully you got these. 1 plus cosine of x plus x times sine of x all over 1 plus 2 cosine of x plus cosine square of x. Or I will also accept this on an assignment, 1 plus cosine of x plus x times sine of x all over unfactor form of this. Okay, either one is exactly the same. Okay, the one on the left is just that some of you like to FOIL things out all the time, and the one on the right you don't have to because it's not going to cancel anyway. Now this one, we are going to start with derivatives of other basic trigonometric functions. I'm going to give you the rest of them because there are 6 trig functions altogether. I'm going to prove one of them, which is the first one right here, which is the derivative of tangent. Okay, some of them I'm not going to prove it. Maybe I'll ask it on a homework or maybe on an exam. Okay, so the derivative of tangent, let's prove this really quickly. So the derivative of tangent with respect to x, remember tangent is really sine of x over cosine of x. Okay, now then I'm just gonna keep on going, right? I'm going to use u and v. So think of this and this. This is a quotient. Okay, so the derivative says that's gonna be, the quotient rule says what? Can you remember? Does it say u prime? Okay, so the first one says u prime. So I'm going to write sine of x, and then I'm going to write prime out here. We'll work on that in a little bit. Then it says times v, right? V is the bottom, which is cosine of x, minus, it says v prime, so I'm going to write everything out first. I haven't done any derivatives yet. I'm just filling in the formula, okay? Times u, which is sine of x, all over v squared, which is on the bottom, cosine of x squared, okay? Then from here, now I will try to do the derivative of sine. The derivative of sine, as we know by now, is going to be cosine of x. Then I'm going to write cosine of x out, minus the derivative of cosine is now going to be a negative sine of x, and bring over the sine of x, all over cosine of x squared, just cosine square of x, okay? This is going to give me cosine square of x on the top. 2 minuses would make a positive sine square of x on the top, all over cosine square of x. Oh my, the top becomes a 1, isn't it? That's going to be 1 over cosine square of x, which is, whoa, secant square of x. Awesome, right? Okay, so y'all, the derivative of tangent of x is just going to be secant square of x. Yes, that's another one that you have to know, okay? There isn't, if you want to derive it from the beginning, I'm all for that, but on the test you might not have time. So if you just have it memorized, it's going to be so much better for you. Okay. The next one, the remaining 3, I'm not going to prove it. I'm just going to give it to you straight up, okay, in which you need to have it all memorized, okay? The derivative cotangent of x is going to be negative cosecant square of x. Yes, memorize that. And the derivative of, with respect to x, of secant of x is going to be secant of x times tangent of x. And the last trig function, the derivative of x of cosecant of x is going to be negative cosecant of x times cotangent of x. Okay, so these are the remaining 4 trig functions that you have to know. Okay. All right, so again, let's recap that really quickly. The derivative of tangent of x is secant square of x. The derivative cotangent of x is going to be negative cosecant square of x. The derivative secant of x has secant in it. The secant of x times tangent of x. The derivative cosecant of x is negative cosecant of x times cotangent of x. Okay, now let's apply it right here. This one, it's I'm just giving you a heads up, it's not going to be as pretty. Okay, so get ready. You're going to need all of the space that's on there. So example 2, find the equation of the line normal, that means perpendicular, right, to the graph of y equals tangent of x over x at the value of x equals pi over 4. To find it, obviously I need a slope. Okay, need the slope. I need m, whatever m is, I'm going to have to find it, and I need a point. And a point. So far, I have an x location of my point, which is pi over 4. I just need now to find the y location. So y equals tangent of pi over 4 divided by pi over 4. Well, I know tangent of pi over 4. Tangent of pi over 4 is a nice number. It's 1 over pi over 4, which is really 4 over pi. Oh my, that's not a very nice number, but that's okay. Okay. So I got my point. Now let's do the derivative to get my slope. So this is going to be y prime equals, I will now use the quotient rule. So here we go. The quotient rule says, do you remember the formula? U prime, right? So I'm gonna write everything out first. Okay, so tangent of pi over 4 prime times what? U prime times what? Oh, I meant x. Ooh, tangent of x prime times what? Times v, and v is the bottom, so it's gonna be x minus v prime, which is x. So I'm gonna write prime first before I go and calculate that, times u is on the top, so that's gonna be tangent of x all over x squared, which is v squared. Okay, now from here I will now attempt to find the derivative of tangents. So the derivative of tangent, if you have not memorized that yet, well, actually I'm gonna give you a second to kind of recall it from your memory. Do you remember the derivative of tangent? We proved it. The derivative of tangent is secant square, okay, of x times x minus the derivative of x is just going to be 1, and bring down my tangent of x all over x squared. Okay, let's keep on going to see how far we can go with this. I'm going to write x in the front of secant square, so that way I'm not confused. That is x squared, it's just secant square of x. And 1 minus tangent is going to be tangent of x, okay, all over x squared. Well, doesn't look like I can simplify this. So guess what? I'm just going to now go and evaluate, because all I need is the slope, okay? This bar right here, class, means I'm about to evaluate for x. And I'm evaluating x as a pi over 4, like that. So what that means is now every time I see an x, I'm going to plug in pi over 4. So pi over 4 times secant of pi over 4, and then I'm going to square that, minus tangent of pi over 4 all over pi over 4 squared. Okay, let's see how pretty this is going to look. All right, I'm going to keep pi over 4 as pi over 4. So pi over 4 stay. Secant of pi over 4 is going to be rad 2. So I'm going to write rad 2 and I'm going to square that. Minus tangent of pi over 4 is a nice number. It's actually just what? 1. All over. I'm going to leave this as a pi square because I don't have a calculator over 16. And keep on going, okay? Then this is going to be pi over 4. Square root square is now just 2 over 1 minus 1 all over pi. Actually, can I multiply by its reciprocal? So let's do this. Because this pi squared over 16, so I'm going to multiply 16 over pi squared, which is now, let's see, I can reduce that down to 2 here. So that will give me, as you can see, and then I'm going to make it into a common denominator. Okay, so this is pi over 2 minus 2, 1 is now 2 over 2 by common denominator times 16 over pi squared, which is now, I have pi minus 2 over 2 times 16 over pi squared. I can reduce this down to 1 and 8. So y'all, I'm almost there to my slope. Okay, so now I have 8 times pi minus 2 all over pi squared. This is my slope, so let's distribute that. This is 8 pi minus 16 all over pi squared. Yes, it's ugly, but there isn't anything you can do about it. So that's going to be my slope, which is 8 pi minus 16 all over pi squared is my entire slope. Can you imagine this? I'm not even anywhere near my normal line. I just got a slope and a point. Okay, so let's write my normal line. Normal line is where I need to do the y minus y1 equals m times x minus x1. Okay, So I got my y value, which is y minus 4 over pi. Now my slope, though, I need to do a reciprocal and opposite, right? So the reciprocal is going to be flipping it. Are you ready? It's pi squared over 8 pi minus 16. And then reciprocal is done, but I need to do its opposite. So negative times x minus pi over 4. Now, all of that, and you want to hear some good news? You do not need to distribute. You can leave it in Poincare form. You do not, again, you do not need to give it to me in y equals mx plus b form. You can leave it to me in Poincare form if it doesn't say what form I want it in. Okay? Happy news! This is the end of our recording today.